Welcome back to the course. This is Introduction to Azure Networking, and this is Lesson 3, where you'll add a second subnet to your existing virtual network, and then deploy your third Azure virtual machine. By way of introduction, just a quick recap that links to the prerequisites for the course can be found in the Introduction section, and links to the deployment scripts which are hosted on GitHub can be found in the Resources section. In this lesson, we'll learn how to reuse and update resources from the deployments performed in the previous lessons. We'll recap on network security groups and flow logging. We'll learn how to create a second subnet within the virtual network to which we'll associate a network security group. How to create a third virtual machine with a network interface attached to the second subnet. How to control virtual network access with application security groups, using them in security rules within network security groups. And how to connect to the virtual machine over the virtual network. We'll verify connectivity over the virtual network. We'll recap on verifying public IP addresses for virtual machines that aren't assigned one, as well as the effective routes and effective security rules of the network interface. Within Network Watcher, we'll learn how to use the Topology, Connection Monitor, and Network Security Group diagnostic utilities, and we'll also provide an overview of flow logging and traffic analytics. Let's review the topology diagram for this lesson. First, let's recap on the resources we're reusing from the previous lessons. These include the resource group, the log analytics workspace and storage account, the first and second virtual machines and their associated resources, and the virtual network and its existing subnet. Inside the virtual network, we now also have a second subnet and its associated network security group. We also have the third virtual machine with its operating system disk and its network interface, which is attached to the new subnet within the virtual network. And now, let's see what this looks like in the Azure portal once everything's been deployed. Here we are in the resource group view, and we can see a list of the resources we've deployed. From the top, we have the existing application security groups used to control internet access, alongside the new application security groups used to control virtual network access. Next, we can see the log analytics workspace and the storage account, which we'll reuse for network security group flow logs. Then we can see the network security groups for both subnets within the virtual network. We can then see the first and second virtual machines and their associated resources. Next, we can see the third virtual machine, its operating system disk and its network interface. And finally, we can see the virtual network to which the network interface is connected. Now it's time for our demonstration, so let's get started. Here we are in Visual Studio Code. We have the deployment script open and our terminal is ready. As usual, before we execute the script, let's review it so we can understand what it's doing. From the top, we have our variables. Here we can see that we're reusing the resource group, location, log analytics workspace, storage account, and virtual network from the previous deployment. Just a quick reminder, in the previous lesson, you likely changed the name of the storage account to be globally unique. Whatever name you chose in the previous lesson needs to be reused here to ensure the deployment completes successfully. We're going to create a new subnet in the existing virtual network, so we need a name for the subnet and its network security group, along with an address prefix. As in the previous lesson, to enable flow logs, we need a name, a version, a collection interval, and a retention. We're then going to create new application security groups to control virtual network access, along with reusing the groups created in the previous lesson to control internet access. And for each of these, we just need their names. We're going to update the configuration of the first and second virtual machines, so we need their names and the names of their network interfaces. We're also going to create a third virtual machine, so we need a name which we'll then use to standardize the names of its network interface and its operating system disk. For the virtual machine, we're again going to reuse the size, the operating system image, and the username and password. And finally, just a quick reminder that it's not considered good practice to store passwords in scripts. Now we have our variables defined, we can start to include the resources in the deployment. All of these resources are now familiar to us from the previous lessons, so we'll start to go through the remainder of the script at pace. First, we can create the network security group for the additional subnet. Next, we're enabling flow logging on the network security group. We're then going to create the application security groups to control virtual network access. Next, we'll create the security rules to control virtual network access, and we'll start with the rule to restrict access, followed by the rule to allow access, and then the rule to deny access. We'll then repeat this process to create the security rules to control internet access. Again, we'll start with the rule to restrict access, followed by the rule to allow access, and then the rule to deny access. Next, we'll create the additional subnet. We'll then create the network interface for the virtual machine, and then we'll create the virtual machine itself. Finally, we'll update the application security group configuration of the network interfaces for the first and second virtual machines. For the first virtual machine, in addition to restricting outbound access to the internet, we'll also restrict access to the second subnet. And for the second virtual machine, we'll allow unrestricted access to the internet and to the second subnet. We can now execute the script, which will deploy the resources. Here we are again in Visual Studio Code, this time with our terminal window maximised. Let's execute the script and observe the deployment. If you're following along, in a moment you may wish to pause the video until the deployment is complete on your side. Now our deployment is complete, let's change over to the Azure portal to review our resources. Here we are in the Azure portal, back in the resource group view. Let's recap on the virtual network. Under Settings, let's go into Connected Devices. Here we can see the network interface of the virtual machines, the subnets to which they're attached, along with their current IP addresses. Next, let's go into Subnets. Here we can see the second subnet that we added, its IP address range, and how many IP addresses are currently available. We can also see the network security group that's associated. Let's go back to the resource group and look at the network security group for the second subnet. Under Settings, we can go to the inbound security rules. Here we can see the rules which restrict, allow, and deny inbound connectivity to the subnet. Note that for the rules which restrict and allow access, we're now using the new application security groups as the source. Next, let's go into the outbound security rules. Here we can see the rules which restrict, allow, and deny outbound connectivity to the internet. Note that for the rules which restrict and allow access, we're also using the existing application security groups as the source. Next, let's go into subnets. Here we can see that the network security group is associated to the second subnet within the virtual network. Lastly, let's go into NSG flow logs. Here we can see that flow logs are enabled, that we're using version 2, that we're sending them to the storage account, and that they're retained for 30 days. We can also see that we have traffic analytics enabled with a processing interval of 10 minutes using the log analytics workspace. Let's go back to the resource group and look at the first virtual machine. We'll again copy the public IP address to our clipboard, as we'll need this again in a moment to be able to connect to the virtual machine over the internet. Under Networking and then Application Security Groups, we can see that the virtual machine, in addition to being associated to the application security group which restricts internet access, is now also associated with the group which restricts virtual network access. Let's go back to the resource group, and this time let's look at the second virtual machine. Under Properties, recall that we can see the private IP address of the virtual machine. We'll make a mental note of this, as we'll also need this in a moment to be able to connect to the virtual machine over the virtual network. Under Networking and Application Security Groups, we can see that this virtual machine, in addition to being associated to the application security group which allows internet access, is now also associated with the group which allows virtual network access. Let's go back to the resource group, and this time let's look at the third virtual machine. In the Overview section, under Essentials, we can see that the virtual machine is running, along with details of the operating system, the CPU and memory configuration, and which virtual network it's connected to. As with the second virtual machine, this virtual machine also doesn't have a public IP address associated to it. Also recall that under Properties we can see the private IP address of the virtual machine. We'll also make a mental note of this, as we'll need this in a moment to be able to connect to the virtual machine over the network. Finally, under Networking and Application Security Groups, we can see that the virtual machine is associated to the application security group which allows internet access. Just a quick reminder that we'll see more about the log analytics workspace and the storage account later in this lesson when we review flow logging and traffic analytics. Now that we've reviewed our resource deployment, let's switch back to Visual Studio Code and connect to the virtual machine. Here we are again, back in Visual Studio Code. From here, let's use the public IP address of the first virtual machine to connect over the internet using the secure shell. Now that we're connected to the first virtual machine, let's validate connectivity over the virtual network. We'll first try to ping the third virtual machine. Here we can see that we haven't received a response to any of our requests. This is expected behavior since we've restricted inbound access to the second subnet from this virtual machine. Next, let's try connecting to the third virtual machine using the secure shell. Now that we're connected to the third virtual machine, let's validate connectivity over the virtual network. We'll again perform a DNS request looking up the Microsoft.com domain using the Google name servers. Here we can see that the request is completed successfully and that Google has responded by providing both the IP version 4 and version 6 addresses for Microsoft.com. Now, let's perform a HTTP request and validate our public IP address in the process. We'll use the same IP info API that we've used in our deployment scripts. Here we can see that the request is completed successfully and that the IP info API has responded with a different public IP address than either of the other virtual machines. Just a couple of quick reminders. Firstly, the DNS and HTTP requests both completed successfully since the third virtual machine has unrestricted outbound access to the internet. Secondly, since the third virtual machine isn't directly associated to a public IP address, Azure randomly assigns a temporary address which we have no control over. In the next lesson, we'll introduce one method to provide certainty on the public IP addresses used within our Azure deployments. Now let's connect to the second virtual machine and again verify connectivity over the virtual network. We'll first try to ping the third virtual machine. Here we can see that we've received a response to each of our requests. Next, let's try connecting to the third virtual machine using the secure shell. Here we are again, connected to the third virtual machine. Both of these connections completed successfully since the second virtual machine has unrestricted inbound access to the second subnet. Now that we've validated connectivity over the virtual network, let's change back to the Azure portal so that we can recap on the effective routes and effective security rules of the network interface. Here we are back in the Azure portal in the resource group view. Let's go into the network interface of the third virtual machine and briefly recap on the effective routes. We'll reorder the routes by address prefix. Recall that we have the 10.1/16 system route for the virtual network, and that we have the quad 0 system route for the internet. We also continue to have the expected system routes for RFC 1918, RFC 6598, and RFC 5735. And as usual, the remaining system routes are for address prefixes assigned to Microsoft and other organisations. Lastly, just a quick reminder that a non-route means that Azure will drop traffic to these destinations. Next, let's view the effective security rules. Here we can see a similar view of the security rules as when we reviewed the network security group after the deployment completed. Next, let's switch over to the Network Watcher to demonstrate the Topology, Connection Monitor, and Network Security Diagnostic utilities. Here we are in Network Watcher. Azure attempts to build a picture of the topology based upon your deployment. Under Monitoring, we'll select Topology. Here we can see we have a deployment in UK South. If we expand the region, we can see our virtual network. If we expand the virtual network, we can see our subnets and our network security groups. If we expand the first subnet, we can see the virtual machines, their network interfaces, their IP configurations, and in the case of the first virtual machine, we can also see its public IP address. If we expand the network interface of the first virtual machine, we can see a complete topology including the virtual network and subnet. Next, let's demonstrate the connection monitor. It can sometimes be useful to monitor connectivity between hosts within the virtual network to a host on the other end of a VPN connection or even to a host on the internet. Under Connection Monitoring, we'll create New. First, we need to supply a name for the connection monitor, along with a location. Next, we can set up the test group, and first we need to specify a name. We can then add our sources. We'll expand the virtual network, followed by the first subnet. We'll select the first virtual machine, followed by its private IP address. We'll then add the endpoint. Next, we can add the test configuration, and first we need to specify a name. We can then specify the protocol, and we'll use TCP. We can then specify the destination port. We'll use the default port for SSH, which is 22. We'll accept the default test frequency of 30 seconds. We'll set the checks failed to 5%, and we'll choose a round trip time of 20 milliseconds. We can then add the test configuration. Next, we can add our destinations. We'll expand the virtual network, followed by the second subnet. We'll select the third virtual machine, followed by its private IP address. We can then add the endpoint. We can then add the test group, and next we can specify the log analytics workspace. We'll use a custom workspace, and we'll accept the default workspace which we deployed for flow logs and traffic analytics. Optionally, we can create an alert, but we'll skip this for now. We can then select Review and Create, and finally we can create the monitor. If you're following along, you may wish to pause the video here until the deployment completes on your side. For the purposes of the demonstration, we'll leave the monitor running for approximately 30 minutes so that we can see some data in the logs before resuming the demonstration. Here we are some time later. Now let's review the data that's been collected by the connection monitor. We can select the connection monitor, and by default the time interval will show the data for the last hour. Here we can see the percentage of the checks which have failed, which is currently 0%, along with the average round trip time, which is currently 1.53 milliseconds. Next, let's demonstrate network security group diagnostics. It can sometimes be useful to see a more detailed evaluation of how traffic is processed by the network security rules within our network security groups. Within network security group diagnostics, let's first test outbound access from the first virtual machine. We'll select our target resource, and we'll choose the first virtual machine. Next, we'll select the protocol, and we'll choose TCP. For the direction, we'll choose outbound, and for the source type, we'll accept the default IP version 4 address. For the address, we'll use the private IP address of the first virtual machine. For the destination IP address, we'll use the private IP address of the third virtual machine. And for the destination port, we'll use the default port for SSH, which is 22. Now we can run the diagnostic. We'll view the details, and we can see that the network security group applied to the first subnet allows the traffic via the default allow VNet outbound rule. Let's rerun the diagnostic, and this time we'll test inbound access to the third virtual machine. For the target resource, this time we'll choose the third virtual machine. For the remainder of the form, we can see that the Azure portal has remembered our previous entries, so we only need to change the direction from outbound to inbound. We can now rerun the diagnostic. If we again choose to view the details, we can see that the network security group applied to the second subnet allows the traffic via the custom restrict subnet inbound rule. Next, let's review the NSG flow logs. Here we are in the log analytics workspace. If we choose logs, we can then search for flow logs. We can then load an example query to the editor. This loads the default search query with a time range of 24 hours, with the results limited to 100. Let's maximize the space for the editor and the results by collapsing the menus. We can now run the query to return a small sample of results. We can now customize the query to our requirements. Let's remove the limit of 100 results and rerun the query. Here we can see that we have over 14,000 results in the last 24 hours. Let's now apply a filter to try and identify all SSH traffic from the first virtual machine destined to the third virtual machine. Here we can see the logs for all SSH traffic sourced from the first virtual machine destined to the third virtual machine. Finally, let's go back to Network Watcher where we can review traffic analytics. Here we are back in Network Watcher. Under Logs, let's choose Traffic Analytics. Here we can see a summary of the flows over the last 24 hours. We can also view a map of our deployment. This summarises all the geographies our virtual machines have communicated with. If we hover over UK South, we can see that we have one virtual network, two subnets, 3 virtual machines, and both of our network security groups have traffic analytics enabled. If we select the region and then close the summary, we can see that the blue lines indicate flows which Azure considers to be benign, and the red lines indicate flows which Azure considers to be potentially malicious. If we close the map view, we can see a summary of the traffic distribution. We can then drill into more detail. Here we can see the distribution by top IP addresses. If we close the detail view, we can then see a summary of the network security group hits. We can also drill into more detail here, where we can see the distribution of security rule hits. Let's again close the detail view, and finally we can see a summary of the application ports. Again, we can drill into more detail, where we can see the distribution of layer 7 protocols. Let's return to the summary view. There are endless areas within this utility that allow you to drill down into very low levels of detail. Spend some time generating traffic within your virtual network, and then come back and inspect the data for yourselves. You might find some interesting results. That concludes this lesson. I hope to see you in the next one, where you'll learn one method to control the outbound public IP addresses used within your deployment by introducing a NAT gateway. See you next time.